Today, on behalf of our team, Franklin, Eduardo and Emily, we will present our systematic mapping study on the automation of repetitive tasks in academic document preparation. This study maps the techniques, tools and methods used to automate processes like information extraction, reference management and scientific writing. Our presentation is organised into 5 sections: Introduction, covering the purpose of this study, Materials and Methods, describing our search and selection protocol, Results, organised by research question, Discussion, interpreting the findings, and Conclusions, summarising our contributions and directions for future work. The purpose of this study is to characterise, identify and classify the approaches used to automate repetitive tasks in academic document preparation through a systematic mapping methodology. Its key contribution is bringing together scattered evidence from the literature to highlight current trends, dominant techniques and research gaps open for future investigation. For our search protocol, we queried 2 index databases, Scopus and IEEI Explore, covering publications from 2022 to 2026. This retrieved 292 records from Scopus and 10 from IEEI Explore, totaling 302 potentially relevant records. Our Boolean search string combined 3 conceptual blocks: document automation terms, academic document types such as research papers and theses, and automation tools like LaTeX and citation management systems. Only peer-reviewed studies in English with full text availability were included. The selection process followed 4 stages. From 302 records, 1 duplicate was removed. After title, abstract and keyword screening, 87 articles were shortlisted. Full text evaluation reduced this to 57 articles. Applying inclusion and exclusion criteria yielded 26 final studies, 25 from Scopus and 1 from IEEE Explore. This relatively small number confirms that the field is still emerging. All screening was conducted independently by 3 reviewers, with disagreements resolved through consensus. This chart shows how the 26 studies distribute across 8 task categories. Content generation and writing is the most frequent, appearing in 9 studies at 34.62%. Information extraction and structuring ranks second, with 7 studies at 26.92%. Together, these 2 categories represent over 60% of all research identified in this mapping. This map visualizes 3 dimensions simultaneously: the automation technique used, the task automated, and the type of academic document targeted. Large language models emerge as the dominant technique, and scientific articles are by far the most targeted document type. We will detail each dimension in the following slides. Addressing research question 1. The 26 studies produced 28 task study associations, since 2 studies address 2 tasks simultaneously. Content generation and writing leads with 9 studies at 34.62%, followed by information extraction and structuring at 26.92%. Workflow automation and citation management each appear in 3 studies, while peer review support and systematic literature review support appear in 2 studies each. For research questions 2 and 3, LLMs through prompting or agent-based strategies dominate the corpus, appearing in 13 out of 26 studies, that is 50%. Pre-trained transformers follow with 4 studies. Regarding tools, 57.69% of studies developed custom in-house prototypes such as SciKgraph or ScholarPhi, while only 15.39% relied on existing commercial or general-purpose tools. Research question 4 asks which document types are targeted. Scientific articles dominate, with 19 out of 26 studies, representing 73.08% of the corpus. Workflows and documentation appear in 3 studies, systematic reviews in 2. Technical reports and STEM documents each have only 1 study, confirming these as largely unexplored areas. For research questions 5 and 6, publication volume grew steadily from 2021 to 2024, peaking at 8 studies, coinciding with the rise of generative AI. 50% of studies are validation studies. The most frequently reported limitations include factuality and hallucination risks at 23.08%, lack of standardized metrics at 19.23%, and limited domain generalization at 11.54%. 3 key findings stand out. First, the concentration around content generation and information extraction over 60% of studies aligns with the maturity of automatic summarization techniques. Second, the dominance of LLMs confirms the broader shift toward large-scale pre-trained models. Third, the prevalence of in-house prototypes targeting scientific articles indicates the field remains in a phase of technological consolidation. To conclude, large language models dominate academic document automation, mostly for writing and extracting information. Tools are still experimental and metrics are not standardized. Future work should cover more document types and build reliable workflows. Thank you. Today, on behalf of our team, Franklin